In this presentation, we will assess the business value of information technology through an analysis of the VISTA data. It is extremely significant to evaluate the business value of information technology because of the high initial costs associated with implementation. One cannot assume that every IT program will be advantageous to the business. Currently, errors in information technology implementation may be due to calculation errors or lack of objective data. With such concrete data, the value of an IT program can therefore be assessed accurately. The Department of Veterans Affairs is one of the largest health systems in the U.S. VISTA stands for the Veterans Health Administration Information System and Technology Architecture, which is an integrative software program that facilitates patient care for veterans. VISTA was adopted in 1996 based on the Decentralized Hospital Computer Program, DHCP, from the 1980s. Within VISTA, the patient's health history, family history, lab results, and current medications are integrated through a central electronic system. Currently, there are over 4 million veterans that use the VISTA system. This slide shows data provided by the Department of Veterans Affairs Office of Budgeting on October 16, 2007 regarding the VISTA program. Here, we see the budget to date, the number of patient records in VISTA, and the cost per patient index over a 7-year period. In order to better understand the data on this slide, we will create a scatter plot comparing IT investments and the cost per patient index. Before we do that, we will observe the relationship between these three different variables. We must calculate their respective correlations based on the data table previously shown. We can graphically compare two of these variables to obtain a better understanding of what is going on. Here we are comparing IT investment and the cost per patient index. Improvements in the cost per patient index is a measure of productivity, shown on the y-axis. From here on, it is important to explain the difference between correlation and causation. Correlation is simply a relationship between two variables, IT investment and productivity in our example. With a value of 0.8923, there is a fairly strong association, but this information is not causal. In order to determine causation, we must compare whether investment led to use, which led to productivity, or whether productivity and investment led to use. After completing the calculations by multiplying the products of each correlation, we have two values, 0.116 and the absolute value of 0.459. Notice 0.116, the latter of the two, is closer to 0. What does this all mean? Since the value of 0.116 is closer to 0, investment did not lead to productivity. Instead, productivity led to increased use. There are a few limitations with the approach presented so far. First, the data is not always readily available for analysis because a given organization may not adequately document all their information. Second, there was a limited amount of data that was analyzed. For more accurate results, obtaining data from a large sample will increase the validity of the work. With the data available, the correlations show the nature of the relationship between different variables. The take-home message here is that we must objectively analyze data in order to determine its true value to the business.